Hello everyone, hope you all are doing well. In this video, we'll discuss the third problem of Biweekly Contest 78. It's a medium level problem. The problem name is maximum white tiles covered by a carpet. So the problem statement says that we are given a 2D integer array tiles where tiles of I is Li, Ri, and all the indices between the given interval, like for example, for every index j lying between Li and Ri, that particular tile is colored by white color. Okay, now we are also given an integer carpet length, uh, that is the length of a single carpet that can be placed anywhere. Now what we need to do is that we need to return the maximum number of white tiles that can be covered by the carpet. So if we look into the diagram, so the input for the tiles is 1 comma 5, 10 comma 11, 12, 18, and all that. So we have 5 intervals, and that is shown in the diagram that tile number 1 to 5 is white, then again tile number 10 to 11 is white, 12 to 18 is white, 20 to 25 is white, and similar is the case with 30 to 32. So these are the white tiles. Now the carpet length is 10. That means we need to place it so that maximum number of white tiles are covered. So, as explained in the problem, in the solution, this one, that if we place the carpet at tile number 10, then we will be able to cover 9 white tiles. So that's why we return answer as 9, because there is no other possibility that placing a carpet in that particular way will return you an answer greater than 9. At max, you can cover 9 tiles by having a carpet length of 10. So that's why we have returned 9. Now we can see that ourselves, that if we place the carpet in any other configuration, like for example, if we start the carpet from index number 1, then obviously less than 9 white tiles will be covered. And again, there could be a possibility that another configuration results in the same number of white tiles being covered, that means 9, but no possibility says that we can cover more than 9 tiles, so we return 9 in this case. If we come to the second example, then we see that again, first interval is like 1 comma 1, the second is 10 comma 11, and we have a carpet length of 2. So obviously at max we can cover 2 white tiles, and so we place the carpet at 10. So 10 and 11 tiles are covered, so we return 2 in this case. Let's look into the constraints. So the constraints are, we can have a total of 5 into 10 raised to the power 4 tiles. Each tiles will obviously have a length of 2. The range can go up to 10 raised to the power 9. Again, the carpet length can also go up to 10 raised to the power 9. And this is very important. The tiles are non-overlapping, so it basically reduces the complexity of the problem. That we'll see in the solution, that how this constraints help us in probably avoiding checking of some cases. So yeah, this is the last constraint. So now let's look at what could be a possible approach for this problem. So if we see here, then uh, we have a line, for example, and we have some tiles. We have some tiles like this, and we need to place a carpet such that maximum number of white tiles are covered, and we are given intervals which tell that where are the white tiles. So give such type of problems are more or less solved by I would say sort of a logic used in sliding window. We'll see how we came to that approach. That is because what are the possibilities? One possibility, suppose we have 3 intervals. One possibility is that we can start placing a carpet from this position. Suppose the carpet extends to here. This is one of the possibilities of placing a carpet. What could be the second possibility? The second possibility, we start from the first index of the second interval. That means the lower range of the second interval. So that will result in carpet placement in this way. The third possibility is that we start from the third tile, lower bound of the third tile, and that will place the carpet in this way. So that means the benefit the so for n number of tiles, we have n number of possibilities that we can start from the lower bound of n tiles. Now what is the other approach? Here we have seen that we are starting from the lower bound of tiles. What could be the other approach? It can be, what could be the other possibility, sorry, that it can be that we start from an index which is not the lower bound of a particular tile, like for example somewhat here. Now if you look here, if we start from here, it will be something like this. It will be something like this. Suppose this is the case. Just a second, let me erase this. uh, yeah, sorry for this one. This is the case, and suppose we start from here, so we see only this part is covered. Now I'm just trying to depict with the help of a diagram. Now if you see that when we started from the lower bound of this tile, we were able to cover some part of third tile as well, right here, third tile as well. But if we start from a couple of index uh, earlier to the lower bound, then we see that some tiles which were covered in this case are not covered here. So that means the number of white tiles that are covered will obviously be less in this case. Now that can be seen in other way as well. So for example, suppose you want to cover the maximum tiles. So obviously greedily what you will do, you will check for every possibility of n tiles, and obviously if you are at nth tile, that means you are starting from the nth, let's take I. So if you are starting from the ith tile, so that means you will try to cover all the white cells in the ith tile, right? Because for n tiles you will be doing it 10 times. That okay, for first tile I'll try to cover it completely, for the second tile I'll try to cover it completely, and so on. We are doing a greedy approach here. So that means when you are at ith tile, you will be starting from lower bound of the ith tile, because for you the only tiles that exist are I to nth tile. In this way we can see the possibilities. Now for all the n possibilities, that means starting from 0, 1, 2, 3 up till n, for all the possibilities we'll see that how many white cells can be covered for that particular tile if we take that tile as the starting index, and we'll return the maximum answer in that case. So that means, let me erase this. The diagram is, I would say, it was just a second. Yeah, now we'll do this. So now what we'll do, so we'll start from this tile. We'll see that suppose the carpet length is L. For simplicity, let's take L. So if this is the starting index, let's suppose this is the starting index, I will take as S. So what could be the maximum index that can be covered? It will be S plus L minus 1, right? If we start from S, so maximum it can go up to is S plus L minus 1, somewhat here. Again, if we start from here, let's suppose take it again S1. Suppose this was S1, this is S2. So what will be the end index? That means where can the carpet go up to? What is the maximum limit of the carpet that we can have? So it will be S2 plus the length of the carpet minus 1. This is the maximum index that can be covered. Now all we need to do is that we need to find that in this particular range how many tiles are white. Again, in the first range, how many tiles are white? So that means for all the n ranges, we need to find that how many tiles are white. So one of the approaches to do that is we start from this, and then we run a loop, a brute force approach. We run a loop and we check up till we see the end index that okay, how many tiles are white. But again, that will time out, because the range, the number of tiles is 10 raised to the power 4, and also the range goes up to 10 raised to the power 9, so it will time out. Another possibility is that suppose we have covered this range. This is the range that we have covered. Now, so we know the number of white tiles in this case. Suppose there is one more tile here. So when we move forward, when we slide this particular interval one step forward, let me erase it to better understand what's the approach. Yep, yeah. Suppose we have the number of white tiles in this range. We have already calculated. Now when we move forward, so obviously we'll be starting from the starting index of the next range, and that is from this. So all we can do is that we can add the number of white tiles in this range and deduct the number of white tiles in this range. We already know what is here. We can minus it and we can add it. So that means no need to do all the computations. Just uh, decrease the count of number of white tiles of the last cell and just increment the count of the white cells in the upcoming tiles. Now upcoming tiles can be one tile, a couple of tiles, or more than that. That we will see in the code. Because again, suppose your end index, we know the starting index is this. Suppose the carpet length is probably 1000, but the next tile that you have is probably the range is 100 to 200. Now obviously the carpet is too long. That will cover the whole tile. We know that. So we need to see that how many tiles it covers. Suppose we have another tile here. We have another tile here. It goes from 250 to 300. This one goes from 400 to 500, right? But this one is, the carpet is so long, it's the length is 1000, so it will cover all the tiles. So that means you have a possibility of adding multiple tiles, but you will be subtracting only one tile. And in this way, using a concept of, I would say, no, this is a sliding window technique. So using the concept of sliding window technique, we have solved this problem. Now let's try to understand it by seeing the code. Yep, let's see the code here. So again, to apply it, we need to sort the tiles by starting index. That's because we will be traversing from the uh, covering the lesser number of, not the lesser, covering the tile which has a lower index, for example. So that means, what I mean to say is that in this example, 1 comma 1 and 10 comma 11 are sorted. So 1 comma 1 comes first and 10 comma 11 comes afterwards, because we need to start from the lower indexes, right? So we sort it based on the first starting index. We have an index right. We'll see why we have done that. Calculated the number of tiles we have and all that. Now now see, we have a loop from I equals to 0 to I less than n. The starting index is the current tile lower bound. So it is tiles of I 0. The end will go up to start plus carpet length minus 1. The same thing that we discussed in the diagram. Now what we do, we run a loop. We run a loop where till we have not reached the end of the array, that means end of the tiles, or we have not consumed all of the tiles, and the current tile can be covered in this range. That means the end, that means the carpet can cover this tile also. So keep on incrementing the count. So till when you need to increment the count? Till you have consumed all the tiles, or or the current carpet can cover this tile as well. So what you will see, if this condition is true, that means this tile, the tiles in this range can be covered. So we just increment current total plus equals to, just add the current range, and we increment the index. We keep on doing it. Now, once this loop is over, what could be the possibilities? The first possibility is that we have consumed all the tiles. Now, if we have consumed all the tiles, that means we just need to compare the answer. Nothing will be added to current total. And another possibility in the same range will be that, so we have covered some tiles, but till the point we have covered, the tile coming just after this has a lower bound which is greater than end. Like for example, suppose the value of end was 500. Okay, so suppose the value of end was 500, and you have covered some tiles, and the next tile that you wanted to cover, but this loop break because of some condition, the lower bound of that next tile is suppose 550. So in that case, this loop break, and you come to this condition, and you know that you can't cover more tiles when you start from the ith index by the same carpet. So we just update our answer if we have a greater value. Or the second possibility is that if you can cover some part of the next tile, if you can cover, so in this loop we have covered the complete tiles, right? But if we can cover some part of the of a particular tile, then what we do is that, of a particular range, then what we do, current total plus end minus tiles of right comma 0. Now what is right? Right is the tile that we skipped in this case. This loop break because at a particular index of right. So that means end minus right of 0. So by giving some example, suppose the value, the end value is 500, and there is a tile which has a lower bound of 480 and an upper bound of 600. So that means some part of this tile can be covered. That means some tiles are white which can be covered by the carpet. So what we'll do, end is 500 minus 480 plus 1. Plus 1 is obviously to cover the range. So that's why we have added this condition. So we just update our answer. And finally, the last step, that I told you, that when we move to the next tile, we just for the next iteration we just remove the count of the white tiles at the current number of white cells in the current range. So we just remove it, and finally we just return the answer. So yeah, this is a sliding window technique. And the time complexity, if we talk about, then sorting takes big O of n log n, and this loop runs in big O of n. So the overall time complexity will be big O of n log n. I hope you learned something new from this video. Please do support this video by giving up a thumbs up. Do subscribe to the channel, and please comment on that video if you feel that something needs more explanation. Then I'll try to explain it in the comments, or probably I'll just update the video. Yeah. Okay. Thank you.